Yes. Nowadays, we see a lot of Facebook's pages and also WhatsApp groups will tell you that the Western world came over, colonized us, and they took over our science. And that's how they had their industrial revolution. The science was really taken from our Vedas, right? Many people are propagating it. And one of the items which I want to talk today is gravity. So the thing which is always told to us is that Brahmagupta had already known the idea of gravity, which he called Guru Twa Akarshan, as in Akarshan being attraction. So there was a force which was bringing down things, which is what gravity is. There is a force when you throw something up, it falls down, and that Akarshan or that attraction is a force, and that was devised in India, and that's what gravity is all about. Let's think about it a little bit. Even the Greek civilization had understood that there must be a force which is bringing things down. In fact, it was felt it will go to places where it belongs to. So things which drop onto earth belong to earth, like when you throw things up, it falls onto the earth. But the fire, because its flames would point upwards, is because fire belongs to heaven, and it was thought that the heaven was up there, right? So giving these things, many civilizations were already conceptualizing the idea of an attraction and a force. But is that what gravity is all about? Let's go back to our school days, right? We talked about Galileo during those times, right? So why was Galileo unique? In the sense that he had done something which was counterintuitive. What is counterintuitive about what he thought about? He thought does not matter whether it's a feather, a ball of cotton, which looks very light, or a steel ball, which looks very big and hard, which if dropped together, if there is no air resistance, will fall onto the earth in the same rate. That's counterintuitive. And that's what gravity is, which we will go back and discover as the small g. Galileo's this counterintuitive idea was a big step for science. Did he do it by himself? He would have referred to many things before, but this was conceptualized by him, and he did experiments to prove this, right? Now comes Newton a little later. What does Newton do? Newton has the law of motion. If you remember, one of the important items in the law of motion is force is equal to mass into acceleration, right? So let us remember that mass into acceleration. We'll later on find out in terms of the gravity, this A is going to become the small g, right? Now, the second thing which he did was to find out that there is a law for gravitational forces, and that's what he said the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance. And there was a gravitational constant, the capital G here, right? Now, let's think about what it does when we think about Earth, right? Force equal to mass into acceleration. And then force is also equal to G into M1, M2 by R square. We know the radius of Earth. We know the mass of the Earth. We cancel the two together, and we can actually calculate the value of small g as a function of the Earth's radius and also of capital G and the mass of the Earth too. Now, because we know the mass of the Earth, the radius of the Earth, and the G was missing. In fact, Newton's work later on led to Henry Cavendish finding the value of G through experimental. So if you know capital G, if you know the mass of Earth, and if you know the distance of the Earth, the radius of Earth, you can actually calculate the small g, and that turns out to be 9.8. And this 9.8 is what we use, right? So to go back and think that very idea of naming that there is an attraction force, which is what was called as Gurutva Akarshan, is solving gravity, is really being naive. Science is not a eureka moment and you solve everything in one point. It's a process. You discover small things and one thing leads to the other. And that's what scientific discovery is all about. Let's go back to another important point. Even the discovery of the gravity, which is the Newtonian framework, does not really work because it was found that the light bends a little bit more. And this bending of the light required us to come up with a new concept of gravity. And that's what Einstein did. He came up with a space-time geometry. And in his special theory of relativity, he gave us a new idea of how gravity works. Is that the final say? It is not, right? Because people are thinking of new ways of reconciling the special theory of gravity and the quantum physics. In that, new theories of gravity are coming up. There is a currently debated idea of gravity, which is called a loop quantum gravity. There are many books. There are even some really good videos for us to understand what they're trying to do here. So to go back and say that we had known all of this before is not just being naive, it's sometimes denying our cultural progress whenever we did whatever we did, and also denying our future. So we have to take what science is debating today and see if we can resolve something. Like Richard Feynman would say, that you never know how the nature works. You just keep on peeling it like onion, right? So the whole idea of science is peeling these onion skins. And are we participating in it? And if we keep on going back and saying that we already discovered it, we knew it, we are not just being naive and stupid, we're denying our future to it, right? Gravity or any science discovery is a process of steps, right from what was decided to be a sort of attraction, a force of attraction, to Galileo deciding, and that was very important, deciding or finding out and telling us that doesn't matter what the mass is, they're going to fall onto the earth at the same rate. Then Newton's law of the motion, then his gravitational idea, and then Henry Cavendish's calculation of G, and then Einstein coming with a space-time geometry to even further redefine it. Maybe the final answer is not yet out there. We need to find out. We need to see if somebody, our niece or nephew or somebody else, will tell us more about it or will work on this, right? But to stick and harp on this that we always knew it is really not taking us anywhere.